Hi guys, in this session you are going to learn about character functions in SAS. Function definition is a function is a component that can accept arguments and perform operation then return a value. Character functions are used to perform only on character data type variables. The syntax is new variable equals to function target variable comma arguments. For every function, syntax is same. The only change is number of arguments. The following are the character functions. In that, first one is substr. Substr is used to extract the string from a sentence. It means in a one sentence, you can extract. It means you can separate that string from a particular sentence, and we write a syntax for that. And syntax is new variable equals to function target variable starting position of the string and number of alphabets from that starting position. Now we write example program for that. Data demo set SAS help dot cars edit is a new variable equals to substr is a function and make is a target variable here, and 1 is a position of a number and 2 is the number of alphabet from that, and run. Before opening dataset, set log is clear, and we are opening demo. Here make our is target variable and the starting position is 1. It means it starts from A and the number of alphabets are 2. It means AC in every observation. Here AU and here BM. And whenever you create a new variable, it will be created at the end of the data set, and that is a named edit, and the starting position is a 1 and the number of alphabets are 2. That's why here only we get AC from a make variable. Like this, you can extract a string from a sentence, and you can also replace a string by using substr. Then how it will be? And remember the data set substr1 a equals to math. Here a is a variable, math is the word in it, and substr is a function, a is a target variable, and 1 is the starting position, and 3 is the number of alphabets from that position, and equals to che. It means 1 is the starting position. It means it starts from m, and number of alphabets are 3. In this MAT, it is replaced by the CHE. This is our code, and put a run. Before opening dataset, log is clear, str1 CHETS. We are creating maths MATHS. Instead of MAT, it is replaced by the CHE. Got it? Like this, we can replace a string in a word or a sentence also. Now the second one is scan. Scan is used to extract a word from a sentence. Now the syntax is new variable equals to function target variable and word number in a sentence. Now we are writing an example program for that. I named the dataset scan, and a equals to, this is my SAS class, this is the sentence, and a is the variable here, and b is the new variable, scan is the function, and a is the target variable, and 3 here is the word number in a sentence. It means what is the 3 represent here? This is the 1 word number, this is the 2, this is the 3. From this code we get in a b is 3. Log is clear, scan, this is the sentence, and the third word is my. We are getting my in the new variable. Like this, we can extract a particular word by giving its number in a code. For example, if you have a large sentence and you need a word in the reverse, it means at the end of the sentence. At that situation, you can't able to count from the starting position, and we can easily simplify by the minus symbol. Then how it will be? And I named the dataset scan1 and this is our sentence. This is my class session, and b equals to scan is our function, a is the target variable, and -2 run. Here what is this minus represent? Simply this minus represent from this end position. It means this is the -1, this is the -2. According to the code, we are getting in b variable class. We are running this code. Before opening dataset, log is clear, scan 1. This is our sentence. This is we get from -2. It means this is the session is the -1, class is the -2. That's why we are getting class here. Like this, we can extract a word from the end side also. And the next one is, if the sentence is separated with a special symbol, then how it will be? Data scan to, and a equals to, this equals to, here equals to symbol is a special symbol. At this situation, how we extract a word from a sentence? Here b is a new variable, and scan is the function, a is the target variable, and 3 already we know in a scan we represented the word number. Here is the 3. Now simply the special symbol is written in a code and runs. If you not give this special character in a code, it will be thrown an error. Now this is the error free. Now we are opening scan 2. Here we are giving the word number 3, and it have a special symbol also. Here you try to give without a special symbol in the code, you definitely throw an error. Now the next one is compress. Compress is used to remove the spaces between the word in a sentence, and the syntax is new variable equals to function and a target variable. Here we don't have any arguments in it, and I named the dataset compress, and this is my class session. In the between the words we have a spaces. Now the b is a new variable, and compress is our function, and a is our target variable, and run. We are running this code, log is clear, and we are opening compress. And the created variable is with the spaces, and the new variable without spaces between the words. By using a compress, we can remove the alphabets from a sentence. Then how it will be? I named the dataset with the compress one, and a equals to this is my class session, and compress is our function, and a is our target variable, and in the code whatever alphabet we need to remove from sentence, that will given in the code. Before opening dataset, log is clear, and compress. Here in the new variable there is no I. Why? Because we are given I in the double quote. Like this, we can remove a particular alphabet from a total sentence wherever it is. Like this, we can remove a more than one character from a sentence also. Then how it will be? And I named the dataset compress 2, and the same example of variable a, and b is our new variable, compress is our function, and a is the target variable. And just like IAS, it means wherever IAS in the total sentence, the total 3 alphabets are removed from the sentence, and run. Before opening dataset, log is clear, and compress. Here the total IAS are removed from a sentence. Like this, we can remove alphabets from a sentence by using compress, and we can separate alphabets and numbers from a sentence also. And one is clear here, the sentence is in the character data type only. And for explain that, I am writing one code dataset here. I named the dataset with the separate and created names variable with the numbers and alphabets in it. Now I named the dataset check1. It's separate. I created another variable C here, and k1 is a new variable, and compress is a function, and names is our target variable, and here double comma is a must and should, and d, here d represent remove digits. It means it plays characters. And then another new variable k2, compress is our function, and names is our target variable, double comma must and should. Next one kd, here kd means keep digits. It means it removes the alphabets. And the next one k3 is another new variable, compress is the function, and c, here c is our target variable, and ab is our removed string from a sentence, and s is removed string from a sentence, and we are running this code. Log is clear, and we are opening check1. Here names is our created variable, c also created variable, k1 is a d for remove digits. It means it's place alphabets, and k2 kd, it means keep digits. It means it removes the alphabets, and k3 it removes the string. Are you got it? Don't confuse here. k1 d remove the numbers, remove the alphabets, keep digits, and remove the string. Like this we can perform different operations by using compress. And the next one is the compel. The syntax is new variable equals to function and target variable. Here also there is no arguments in it, and I named the dataset compel, and a equals to new variable. This is my slash session, and b is the new variable, and compel is our function, and a is the target variable, run. And log is clear. Compel, here it removes all the spaces between the word in a sentence and gives one blank. Then what is the difference between compress and compel? Compress remove the each and every space between the word in a sentence, but compel it remove the space and give only one space between the words in a sentence. Next one is strip. Strip is used to remove the trailing space and leading space. I will explain what is the trailing space and leading space. And the syntax is new variable equals to function and target variable. Here also it don't have any arguments in it. And I enable the dataset trim1, a equals to space. This is my class session, and space. Here the space before a sentence is a trailing space. The space after a sentence is a leading space. Okay, now we are writing code. B is the new variable, strip is a function, a is the target variable, and run. We are running this code. Before opening dataset, log is clear, and we are opening trim1. Here a variable with the leading and trailing spaces, but in the B it will be removed both the trailing and leading spaces. And then now the next one is cat. Cat is used to joining the two variables, and the syntax is new variable equals to function variable 1 comma variable 2. And I named the dataset cat set sash help dot cars. Again we are taking cars, and edit is a new variable, and cat of make and type run. In the cars dataset already we have a make and type variables. We are joining the two variables by one variable. Here log is clear. We are opening cat. Previously it have a make variable and a type variable. In the edit it will be joining two. Got it? Like this we can join two variables in one variable. Here when we applying cat, it is created with the spaces between them. Why? Because and this observation have a leading space and this observation have a trailing space. By the cat we can't able to remove the spaces between these observations. Then what is the solution for it? Simply we can apply compress on it to remove the space while applying cat. And I named the dataset cat1 set sash help.cars. edit equals to compress of cat. Simply compress is remove the spaces between the words in a sentence, and cat is a joining two variables. Okay, and run. Before opening dataset, log is clear, cat. Okay, and already we have a make and a type variables, and edit is without spaces. Why? Because we are using compress. And the next one, concatenation. Concatenation is used to joining the two variable as like a cat, but by using symbols. Here we are not using any function in it. By the symbols we can joining the two variables. Then how it will be? And name the dataset demo1, set as help.cars, edit 1 equals to strip of make. Then why we using a strip here? Strip is used to remove the trailing and leading spaces, and a pipe symbol. Between that pipe symbol we are giving double quote and strip type run. Here what is the difference between these two situations? In the cat, by using symbol. Simply in the cat we using just a cat function in it, and here without using cat function we just give a pipe symbol between the variables. Now we are running this code. Log is clear. We are opening demo, and simply make and type are the joining variables. At the end we are simply get by joining these two observation in a one variable, and here we have a one space between the two observations. And in this situation, if you want to space between the two observation in a variable, and if you want to any special character between that observation in a new created variable, then how it will be? And to need a space between, and I named the dataset demo2, set as help.class, edit is our new variable, and strip of make is the variable here, and a pipe symbol and strip of type run. Here whatever you give between this space, if you give a space, you get a space between these two variable observations, and if you give any special character instead of space, you get that special character between that observations in a new created variable. We are running this code. Before opening dataset, log is clear, and I am opening demo. And this is a make variable, this is a type variables, and at the end we are getting space between these two observations. If you want any special character or any symbol between these two observations, simply you mention between this. And the next one, index. Index is used to find a position of a word or alphabet in a sentence. Syntax is new variable equals to function target variable target word or alphabet. If you give a target word, it gives a position of that word. If you give a target alphabet, it gives a position of that particular alphabet. And I named the dataset check set as help.class, and name one is a new variable, and index of name comma a. Here name index is a function, name is a target variable, and a is a target word, or here is a alphabet. And one more thing, it is a case sensitive. Before opening dataset, log is clear, and I am opening check. Here target variable is the name, new created variable is the name one. What is the index give? It just give a position of a word. Here it is a case sensitive, that's why capital A is not considered, it's just a give a 0. 0 means you don't have that particular target where observation in it. And here the second position of a, that's why it give it 2. And here also the position is a second, that's why it's give a 2. There is a no a in it, that's why it's give a 0. Like this, it give a position of a particular alphabet or a word in a observation or a sentence. But in a real-time scenario, we are not using index like this. It means we don't need a position of a character or a word in a real-time scenario. Then how we use this index in a real time? In the real-time scenario, data check1 sets as help.class. In the if statement, index of name, index is a function, name is a variable, a is a target alphabet, and greater than 0. I will explain what is the greater than here. Then name1 equals to name. Here new variable is the name1. Then it will be name. And this condition is satisfied, then new variable will be created, otherwise it's not created. It means simply true. When we give a greater than symbol in this for this condition, if it is satisfied, then new variable will be created. If it is not satisfied, it means if you give equals to 0, it is not satisfied. Then name2 equals to name, and for not satisfied are false. Right. What you understand here, simply if it is greater than 0, then condition is true, name1 will be created. If it is equals to 0, it means if it is condition is false, then name2 will be created. Now we are running this code. Before opening dataset, log is clear and check1. Here name1 is a true. It means if that variable have a, then name1 will be created. If the variable don't have that small a, name2 will be created. Are you got it here? Here a is there. It means the first condition is true. Then variable is created name1 from the name. And wherever that condition is false, it means if you give equals to 0, equal is a false, it means not satisfied, and greater than is a satisfied, it means it is true. Got it? Like this we use the index function in a real-time scenario. And the next one is translate. Translate is used to replace the alphabet, and the syntax is new variable equals to translate variable replacement, whatever you want replacement, and the target. I will explain the code. I named the dataset trans, sets as help.class, and new is a new variable here, and translate is a function, name is a target variable, and what you want to replace xy, and what is a target ar, and you can use more than one alphabets also. Before opening dataset, log is clear, trans. Here new is our new variable, and wherever ar, it will be replaced by the xy. Clearly observe, here is the ar. Instead of a, it will be replaced by x, and instead of r, it will be replaced by y. And wherever a, here a is there, carol, and that a is replaced by x, r is replaced by y. And here Jane is there, and a represent x, that's why only x is replaced. Okay, like this we can replace a string by another string. And the next one is transword, to replace the word. I will explain what is the difference between translate and transword. I give a syntax here, and syntax is a slight difference. In the translate, first it is a replacement, but in the transword it is a target. In the translate, second is the target. In the transword, second is the replacement. That is the syntax different. And here translate is used to replace the alphabets, and the transword is used to replace the word. This is the difference between translate and transword. I am explaining the code for the transword. I named the dataset transword, sets as help.class, and new is our new variable, transword is a function, name is a target variable, ar is a target here. Keep it in mind, the syntax is a different for translate and transword. Xs is a replacement, and you can use a more than x. Before opening dataset, log is clear, transword. Here wherever ar is there, it will be replaced by the triple x. Only the combination of ar only. Are you got it? Ar, combination of ar only. What is the difference between this translate? Translate wherever A is there, it don't need the combination of words we give in the target or replacement. But in the trend word, it need a combination of target. Or you got it, the difference here. Instead of A, it is replaced by X. Wherever A is there, it is replaced by the X. Wherever R is there, it is replaced by the Y. But in the trend word, it need a combination of alphabets. It means it need a word to replace. Wherever AR combination is there, it means wherever the word is there, it will be replaced. Wherever alphabet A is there, it will be replaced. This is the difference between translate and transword. Observe the data sets also here. Wherever A is there, here there is a no AR. Only A is there, but it is replaced by the X. In the transword, here A is there, but it is not replaced. Wherever here AR is there, it will be replaced by the triple X. Got it? Like this, translate is replace the alphabet, transword is replace the word. Please subscribe my channel, click the bell icon, like the video and comment below, share with your friends. Thank you. Support me.